Welcome to Pre-Calculus. This video is over sequences and series, and more specifically we're going to talk about arithmetic sequences in this video. So we ended the last video about introduction to sequences with this idea that there are three different types of sequences out there. This is again how I look at it. There are arithmetic sequences, geometric sequences, and all others. So in this video what we want to do is focus on arithmetic sequences. And let's just get right into it because arithmetic sequences are unbelievably easy to work with. So first off, an arithmetic sequence is one in which the term values increase or decrease by the same constant. So for example, in this first problem we see here, the terms are going up 4, up 4, up 4, up 4, up 4. So each term is going up 4. So 4 is that constant that we are increasing by. In this next example, it's pretty quick to see that each term is going down 5, down 5, down 5, down 5. So in this problem, the common difference is 5. Each term is going down 5. So any sequence that is going up or down by a constant value is considered to be arithmetic. Now, notice that there is a common difference between each pair of consecutive terms. So if we go back to this first example here, 3 minus 7 is 4, 11 minus 7 is 4, 15 minus 11 is 4, 19 minus 15 is 4, 23 minus 19 is 4. If you subtract any term by the one previous to it, you will always get that common difference. In this other example, 3 minus 8 is negative 5, negative 2 minus negative 3 is negative 5, negative 7 minus negative 2 is negative 5. You get the point. So we call this common difference D, and that's going to be a really important number to know when we talk about describing an arithmetic sequence. So in this first case, the D, the common difference would be 4, and this second example here, the common difference would be negative 5. And again, it's very easy to find that common difference. Just subtract any two consecutive terms. Just make sure you do the term minus the term beneath it. So again, you're going to do like the third term minus the second term, or the fourth term minus the third term, or the fifth term minus the fourth term. You get the idea. And that's how easy it is to find that common difference D. Now, what we want to be able to do, right, this is what I tried to emphasize in the last video, is extremely important to find the nth term. And the nth term is a formula to find any term you want. And this is awesome. If you think about it, arithmetic sequences are linear functions because a linear function is a line that goes up by the same value every time, right? It has a common slope, and it's a consistent slope. So arithmetic sequences really are just linear functions. So again, the idea here is this is kind of very generically speaking. So your first term is just A, your first term, whatever it is. And then your second term is adding that common difference. And then the second term, or excuse me, the third term is adding 2 of those differences. And then adding 3 of those differences and dot, 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 dot. So here it is. Here is very simple way to find a formula for any term. And I can't emphasize this notation enough. This stands for the nth term or any term. And again, it's awesome because you can find any term you want. If you want to know the 99th term, plug in 99. So again, here is the formula for this. I know it's a little bit confusing, so let me define everything. So to find a formula for any term of an arithmetic sequence, the first thing you need is your first term. You need to know the first term. A sub 1, that is the first term. And you need to know that. That goes right there. Plus, you're going to take that common difference D, right? How do you find that common difference D? Remember, you subtract any two consecutive terms. Usually you could just kind of see it by looking at the numbers. And then you're going to multiply that by n minus 1. Okay? Now, I do say down here in parentheses that after we fill in all the blanks, we're going to fill in the first term. We're going to fill in the common difference. N is your variable, so n stays n. You don't change that. Once you do that, we do distribute the D and then kind of simplify the function. And we'll see that in this very next example. So again, the important thing is that you understand how easy this formula is. This is a formula to find any term you want, but I can't emphasize enough, you could only use this formula if you are arithmetic. So here's an example. Given the following sequence, find the formula for the nth term, and then use that formula to find the 51st term of the sequence. So if I was given this on a test or quiz, the first thing I do is I'm going to start noticing, okay, 8 plus 9 is 17. 17 plus 9 is 26. 26 plus 9 is 35. So it looks like the common difference is positive 9. And then I'm going to note that the first term is 8. And those are the only two things you need to create the formula. So a formula to find any term is going to be the first term plus that common difference times n minus 1. It's that easy. Now again, what I noted on is that we like to clean this up. So I'm going to go and distribute the 9. So I get 8 plus 9n minus 9. And then of course we can combine the like terms. So that's going to be 9n, 8 minus 9 is negative 1. So there is a formula to find any term we want. Now again, this right here is not wrong. I just cleaned it up. I simplified it. But again, I like to always kind of just make sure, prove that it works. Why not, right? Why not check that you're right? So let's find the fourth term. I know the fourth term is 35. Let's just prove that this works. To find the fourth term, I'm just going to plug in 4. So 9 times 4 minus 1. 9 times 4 is 36. 36 minus 1 is 35. So I have just kind of verified that it does work. Okay, now the second part of the problem said, okay, after you do all that awesome work, can you please go ahead and find the 51st term? And that's the beauty of the nth term formula, is you can find any term you want. All you got to do is plug in 51 minus 1. Feel free to grab a calculator. I know that I'm grabbing my calculator right now. I can't do that in my head. And I get 458. So the 51st term is 458, the 51st term. So how easy is that? Very, very, very simple. You only need to know 2 numbers, and they're really not that hard to find at all. All right, let's do a second example here. So once again, they want us to find a formula for the nth term, and they want me to find the 20th term after I find that formula. So again, I'm looking at this, and I notice that it goes down 6, down 6, down 6, down 6. So the common difference is negative 6. It's going down 6. That's super important to note. And then again, I need to know the first term, which is 12. And again, how awesome, guys. Those are the only 2 things you need to create the formula. So the formula, now, hold on 1 second. I can't emphasize enough. I said this earlier, I want to say it again. I can only use this formula if I determine this is arithmetic. And the fact that every term is going down 6, down 6, down 6 guarantees it is arithmetic. So again, first term, 12, plus the d value, which is negative 6, times n minus 1. That's the formula. That technically is correct, but we like to clean it up just to make it look a little bit nicer. So I got 12, distribute, I get negative 6n, distribute, positive 6. So I get the nth term is negative 6n plus 18. The 12 and 6 makes an 18. And again, that's just the same formula, just cleaned up. And again, that looks linear, right? Because we're just using n as the variable, whereas a function might use x. I mean, if this was negative 6x plus 18, you guys would all be like, oh, that's a line. That's linear. How easy is that? Now, again, I do like to always make sure it works. Let's just check the third term real quick. So negative 6 times 3 plus 18. Negative 6 times 3 is negative 18. Negative 18 plus 18 is 0. So it does work. The third term is, in fact, 0. And then they wanted me to do a little extra work here to find the 20th term, and that's the beauty of the nth term formula, is all I got to do is plug in 20 to get the 20th term. Okay, so negative 6 times 20 plus 18, how easy is that? Negative 102 is the 20th term.